through our introductory trigonometry. Okay, number 7. We talked about last time we were together the difference between statute miles and nautical miles, or the reason why we have two different ways to measure distance that way. So number 7 should be an easy one. Let's see, Megan McCarty, she flies a distance of 2698 statute miles. And flight timer based on nautical miles. How many nautical miles is that? So 2698 statute miles. I'll just say SN. How would we figure out how many nautical miles that is, using the conversions, which by the way you do not have to memorize. Using those conversions, what would we do to convert this into nautical miles? Multiply it by 0.87, exactly. So if you take this number times 0.87, we're going to get whatever we get, and that's how many nautical miles it would be. So 2698 times 0.87. Did you get 2347.26 nautical miles? That was easy enough. All right, so now we've got our compass. I think we talked a little bit about this the other day. Here's our compass, and we know this is 0, 90, 180, 270. Okay, now, we know this is north, south, east, and west. Now, just a little, maybe new vocabulary, maybe not new vocabulary for you. If I draw this perfect diagonal right here, split that, make that 45 degrees, that line would be called the northeast line. Does that make sense to you, that this is the northeast quadrant? And this would be the southeast quadrant, and so on, okay? Now, those splits can themselves be split. So how big would this angle right here be then? Now remember, this was 45, so this one's gonna be what? 22.5. And that's 45. This one's gonna be 67.5. Is that okay with everybody? Now, and we can do the same thing in every quadrant. I'm not gonna go through and draw all those there. A lot of them are drawn for you, but I'm not gonna do them all. But I want you to know how these are named. This line right here, okay, this is northeast, right in the middle is northeast. This one is called north-northeast, and this one is called east-northeast, because this one is on the north side of the northeast. It's in between north and northeast, so it's called north-northeast. This one is in between northeast and east, so it is called east-northeast. So let's look over here. This would be southwest. Northwest, maybe? That would be northwest. If I split this right here, I can find the angle, but what would this one be called?
West-northwest.
West-northwest, that's exactly right. And if somebody said to you, what is the angle measurement for west-northwest? That means you come all the way around to here. So what would that measure be? 292.5. That's exactly right, because it's 270 plus another 22.5. Easy. All right. Northeast, what's the degree measure for northeast? Well, I have that one marked, 45. North-northeast, I have that one marked, 22.5. And west-southwest, now I don't have that one marked. This would be southwest. And then west-southwest would be here. So what would be that angle for west, southwest?
247.5.
How did you get, you're right, how did you get 247.5?
Subtract 22.5.
From 270, yeah, does that make sense to everybody? Easy. Okay, so keep that in mind, we're gonna do some word problems later on. Actually quite a bit later on, where we have to know what these angle measurements mean, so we can figure out whatever we need to know. Okay, 4.1 done, due on Wednesday, okay? Perfect. 4.2, here we go. I tried to make a big deal about it, that the only time angles are measured this way, starting up here, the only time is navigation. In regular trigonometry, every other situation other than navigation, angles are going to be measured in what we call standard position. And standard position means that we start measuring on the positive x-axis. So this is 0. If you are doing a navigation problem, a ship is sailing on a course, a plane is flying, whatever, this is the setup. Otherwise, this is the setup. And the measurements are counterclockwise. So 0, 90, 180, 270. This is for what? I don't know. It's just the way it is. This is how we do it. So when I say to you, draw an angle of 60 degrees, everybody, you, me, the person next door, the person in France, everybody's going to draw an angle of 60 degrees like this. That is standard position. Now, if the angle is a negative angle, which we have in trigonometry, you didn't have them much in geometry class, but angles can be negative. When they're negative, all that means is instead of rotating counterclockwise, going up this way, they go down. So negative 60 degrees would look like this. So negative just means you're going in the opposite direction. Okay? All right, now we've got our basic definitions of right triangles. You guys know you've worked with sine, cosine, and tangent before. You probably, hopefully, have talked about Chief SOHCAHTOA, chief of the trigonometry tribe. Sine, cosine, tangent. Opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. And I drew the picture there, or cut it out of your book. Whenever you have a right triangle, obviously the side across from the 90 is always going to be the hypotenuse. Which one is opposite or adjacent depends on which angle you're looking at. So for example, if I am looking at this angle, this is my angle, then this side would be opposite and this side would be adjacent. Opposite means across from, adjacent means next to. If I had the same triangle, but this was the angle I was looking at, then this would be opposite and this would be adjacent. So you can't label opposite and adjacent until you know where your angle is. And then as soon as you put your angle in, then you're good to go. Sine, cosine, tangent. We're good on that. The buttons on our calculator. You've done those before. Did you do the reciprocals last year? Secant, cosecant, cotangent. No? Don't sound familiar? All right, then let's take a little bit deeper look at those just to make sure. Now, sine, cosine, and tangent are the big three. They are the buttons on your calculator. But sometimes we need, especially in calculus class, we need to talk about these reciprocals. So we have secant, which is abbreviated SEC. We have cosecant, which is abbreviated CSC. And we have cotangent, which is abbreviated COT. Secant is the reciprocal of the cosine. These are called the reciprocals. Secant is the reciprocal of the cosine. So secant equals 1 over cosine. So secant theta equals 1 over cosine theta. Cosecant is the reciprocal of the sine. So cosecant theta is 1 over the sine, the reciprocal of the sine. And then cotangent's the easy one. It's the reciprocal of the tangent. So if you know that the cosine is 1/3, then the secant will be 3 over 1. They're reciprocals of each other. Sine is the reciprocal of the cosecant. Cosine is the reciprocal of the secant. And tangent's the reciprocal of the cotangent. So if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. Okay? So you need to remember SOHCAHTOA, which I think you already know, and then you need to remember what's the reciprocal of what. I had a kid tell me that a while back that she remembered because the cos don't go together. In other words, cosecant is with regular sine, and cosine is with regular secant. I don't know if that helps you or not, but that's how she kept them straight. You will come up with your own way. All right, the last little bit of necessary information from geometry class, your special ed triangles. You remember your 45, 45, 90 and 30, 60, 90 triangles. You remember the relationships of the sides, the 1, 1, root 2, and the 1, root 3, 2 relationship. It's drawn down there at the bottom. If you have forgotten that, restudy that. It's going to be necessary in order to do the very next problems that we're doing. These are no calculator problems, so you are going to find the sine of 30 degrees. Over pi over 6 radians. So, first of all, I'm going to draw 30 degrees. There's a 30-degree angle. Remember, I start measuring here. So that's a 30-degree angle. I dropped a perpendicular down to create a triangle. And that triangle is special because since that's a perpendicular, this angle up here would be 60. And the sides of a 30, 60, 90 are known. Across from the 30 is 1, the hypotenuse is 2, and the 60 gets the root 3. This is my angle. I'm doing the sine of 30 degrees. So this is my angle, meaning this side is opposite, this side is adjacent, and this side is hypotenuse. Does that make sense to you? So now I know my answer. Sine is opposite over hypotenuse, so the answer is 1/2. Cosine 45. Same thing. Draw a 45-degree angle and drop a perpendicular so that you've got a triangle. If we're going to have opposite, adjacent, hypotenuse, we need a triangle. So we'll just drop that perpendicular straight down. Now I have a 45, 45, 90, right? So the sides are 1, 1, root 2. I have to have those memorized if I don't already. Now this is your angle, always at the origin. You're always going to be looking at the angle at the origin, because that's how you drew that 45. So here's my opposite, here's my adjacent. This, of course, is my hypotenuse. Cosine adjacent over hypotenuse. 1 over root 2, which I'll rationalize and get root 2 over 2. That's called the exact cosine of 45 degrees. All right, tan 60. See if you can figure out the tangent of 60 doing exactly the same strategy. Did you draw 60? And make a triangle, and then across from the 60 goes the root 3. Tangent is opposite over adjacent. Did you say root 3 over 1 or root 3 as your answer? Now, using the same triangle, I'm going to do the next problem because it's the secant of 60. So here's what's going through this weary old mind. Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. So hypotenuse over adjacent would be 2 over 1 or 2. Cotangent 30. I'm going to come back to this picture. Cotangent. Adjacent over opposite. Right? So adjacent over opposite. The cotangent of 30 is root 3. Look at this, guys. The when we talk about the thing, it means complementary. So the tangent of an angle is equal to the cotangent of the complementary angle. So what does it mean for angles to be complementary?
They add to 90.
They add to 90. Do 30 and 60 add to 90? These are complementary angles, so their co-functions are equal. The cosine of 50 is equal to the sine of 40. That co stands for complementary. So if I tell you what the tangent of 17 is, you can tell me what the cotangent of 73 is, because they're always equal. Interesting. Interesting. Okay, cosecant 45. I can use this picture right here. Cosecant 45. Here's a picture. Cosecant is the reciprocal of sine. So hypotenuse over opposite. Hypotenuse over opposite will be root 2 over 1 or root 2. keeping up? This is big. It's very simple, but it's huge, because later on we're gonna learn formulas that allow us to find other angles, like we can find the, I don't know, the tangent of 75, but we have to break it down into 45s and 30s. These are gonna be the keys to everything. All right, number 2. Given an acute angle theta, what does acute mean? Less than 90, so it's here in quadrant 1 somewhere. There's theta. The sine of theta is 5/6, which means opposite over hypotenuse is 5/6. Find all the rest of them. So what's the cosine? What's the tangent? What's the secant? What's the cotangent? And what's the cosecant? Now, one of these we know right now without doing anything.
The CSC.
We call that the cosecant,
Yeah.
and the cosecant will be 6/5, because the cosecant is the reciprocal of the sine. What about the rest of them?
Do we find the other side?
We gotta find the other side of the triangle first, because don't we need the adjacent side? So how shall I do that?
Pythagorean.
The Pythagorean theorem? That's a right triangle. If you're doing SOHCAHTOA, it's a right triangle because you got a hypotenuse, okay? So you got a right triangle here, so I'll call that x. X squared plus 25 equals 36. Is that okay with you? So x is going to be the square root of 11. All right, great. What's your cosine? Square root of 11/6, because cosine is adjacent over hypotenuse, which automatically means your secant is 6/√11. Now I gotta check with Mr. Shadio. I don't know if he's gonna make his kids rationalize or not. You know how to do it though if you need to, right? I'll check and get that figured out. All right, what's our tangent? 5/√11, which makes the cotangent √11/5. And if we need to rationalize this one, it'd be 5/11/11. Powerful. If you have one function, you automatically know all the rest. You figure them out. Why was knowing this was an acute angle important?
To know what angle we're trying to find.
To know where to draw it, right? Because there are other triangles that have 5/6. Look at this one. Isn't that sine also 5/6? But that would make this negative, wouldn't it? So I need to know which quadrant I'm in before I start drawing my picture, because I could be in any quadrant and do this same process. That's coming soon, but first we gotta type in on our calculator. I want you to notice something. Some of this we've already talked about, some we haven't. The first column, ACE, those numbers look different than the second column, B, D, F. In B, D, and F, do you see a degree mark in every single one of those? That means that those angles are measured in degrees. In A, C, and E, do you see any degree marks? That means those angles are measured in radians. Your calculator needs to be told whether the angle is going to be in degrees or radians. So we're going to do the first column. We're going to do A, C, and E first. And we're going to set our calculator in radians, because those are all radian angles. So we're going to mode, And for me, it's the third one down, but I have a radian option and a degree option. You might have other options too. Highlight radians. And now every angle you put in, the calculator's gonna interpret it as a radian, which is what I want in the first column. So sine 3. It doesn't tell me how to round, so let's round off to the 10,000, 4 decimal places. What did you get for sine 3? 0.1411? That's it. Tangent, 1.8 pi. Use your pi button. Tangent, 1.8 pi. What'd you get?
Negative 0.7.
Negative 0.7265. Oh crap, I don't have a secant button. I paid a fortune for this calculator and I don't have a secant. I gotta remember what secant is. What is secant? Reciprocal of cosine. So 1 divided by cosine pi. I got -1, did you? Now, I know what some of you are thinking. We're going to talk about it, but I'm telling you right now, if you want a secant on your calculator, there's no shortcut. You're not, you see a button on here you think might be it, it's not. If you want a secant on your calculator, it's 1 divided by cosine, period. Okay, now let's go back to mode. Let's change our calculator over into degrees. And now we'll do the second column. Every angle I put in now is going to be in degrees. So I'm going to press cosine 48. Okay, do you remember how to get that degree mark? Who remembers? I go to angle, so second angle. Angle is my axe button right here. We did this the other day. And it's right there, degrees. And then 10 second angle minutes. Let's see, rounding this one's gonna be hard. Did you get 0.6670? Okay, type it again. Press cosine 48 second angle degree 10, was it 10?
Yeah.
Second angle, go down to minutes. .6670, everybody okay with that? All right, cosecant, time out. How do I get a cosecant? 1 divided by, so 1 divided by sine. 239 second angle degree. 11 second angle minute, and then this is so odd, 15 alpha plus. Remember that from the other day? And enter. Negative 1.1644. Negative 1.1644. And then finally, cotangent will be 1 divided by tangent, 173. You do not need to put that degree mark in because your calculator's in degrees. You use that degree mark as a separator from degrees to minutes to seconds. You don't need to type it in if you don't, all you have is 173. I got negative 8.1443. Common calculator errors. Oh my God, you have no idea how many kids have missed so many points because of this. First, you gotta be in the right mode. Obviously that makes sense, right? But if you mean sine 62 degrees and you're in radian mode, you will get the wrong answer. So you must tell the calculator what mode you're in. Inverse cosine, inverse sine, inverse tangent are not secant, cosecant, cotangent. If you want Cosecant, it's 1 divided by sine. That's how you do it. Cotangent, 1 divided by tangent. Those other things are other things that we will learn how to do, but they are not the reciprocal functions. They look like they might be, they are not. If you want to square a function, we will write, when we put powers on functions, we will write them the way mathematicians write them. So we will write sine squared 30. That means the sine of 30 squared. So if you're typing it in on your calculator, you have got to make sure when you hit sine, it's going to put that parentheses in. You need to square the whole thing. You understand that if you type this, it will be wrong? Yeah, so be careful about that. If you're putting in powers, make sure you got your parentheses. And then always close the parentheses. So if you want to do sine 45 degrees plus tangent 10 degrees, remember to close the parentheses before you do the next operation. Sounds easy. Please, please, please remember to do it. All right, number 4, we're going to solve some triangles. Does anybody know what we mean by solving a triangle? You actually did it in geometry, you may have forgotten. What do we mean by solving a triangle?
Find all the sides and angles.
Yep, find all the sides and angles. I don't know if you said that, but you're a genius, thank you. Find all the sides and angles. Now, next thing. When we label a triangle, we use capital letters for the angles and lowercase letters for the sides. So across from angle H will be side H. Across from angle C will be side C. And across from angle S will be side S. Now I tried to be clever with CHS, but the capitals and lowercase, it's kind of hard to distinguish. These are lowercase letters, okay? So with H, it's obvious. This is a little c and this is a little s. That's how they're configured. So they tell me that angle H is 32 and that side S is 15.4. My job is to find everything else. Obviously, I know angle S is 90. So I have to find angle C, I have to find side C, and I have to find side H. That's my job. So who has a thought?
We know
about
angle
Angle
C.
C is 50.
Angle C is 58 because the angles of a triangle add up to 180. These two add up to 90, so that's a gimme. Got it? Perfect. Now, we just got to decide. Okay, let's find side C first. Okay. Now, I know the hypotenuse. I know this angle is 32, that was given, so I'll just use that 32. I could use 58. I'll set it up differently if I do, so I'm going to use 32. If I want side C, isn't this the adjacent side for 32?
Yep.
So cosine 32 equals C over 15.4. The cosine of the angle equals the adjacent side over the hypotenuse. If I would have used 58, which is fine, finding side C though, I would have used sine 58 equals C over 15.4. All right, solving this. Make sure I'm in degrees, because that's a 32 degrees, so I'll go to node, I am. So 15.4 times cosine 32. For side C, I got 13.06. I I'm just randomly rounding. Did you get 13.06? Now, I gotta find side H. How do you wanna find side H? We could do the Pythagorean theorem. Now, kids, if you're gonna do the Pythagorean theorem, then I want you to use the number that's on your calculator. So the Pythagorean theorem would say that 13.06 squared plus h squared equals 15.4 squared. When you square that, I want you to square this right here. So I'm gonna take 15.4 squared minus second answer squared. And then I'll square root that. The general rule of thumb is, if you can avoid it, don't use rounded off answers. So I would prefer you not use the Pythagorean theorem in this situation, but if you do, it's okay as long as you use the number in your calculator. Don't use 13.06 because it's rounded off. So what did you get for H? I got 8.16. Anybody else get that? Perfect. And the triangle's done. We solved it. Finished. I would have probably rather, there's nothing wrong, like I said, the way we did it, there's nothing wrong with it. I probably would have said cosine 58 equals h over 15.4 and done it that way. We're supposed to use given information when we solve, but as long as you're not rounding it off, it's okay. Emma, you all right? Yeah, I saw you looking, I wasn't sure. Everything okay? Okay. All right, one more, number 5. Another triangle to solve. And we're told that C, and that's a little c, is 11.6, and little s is 15.2. And our job is to solve the triangle. So can we use the Pythagorean theorem without issue this time? Yeah. So 15.2 squared minus 11.6 squared, and then I'll square root that. I got 9.82. Did I do okay?
Yeah.
I need my angles now, so I don't know. I'll just find H first. It doesn't matter one bit. I find one of them first, so I'll find H first. Any thought on that?
Could he do inverse?
We know the cosine of whatever H is has to be 11.6 over 15.2. Would you agree with that? The cosine of this angle equals that fraction. So the angle itself is the angle whose cosine is 11.6 over 15.2. This notation means the angle whose cosine is. So whatever number you've got here, so if I said 0.2, it would be the angle whose cosine is 0.2. So those buttons, these buttons, give you an angle. They're going to give you an angle. So second cosine 11.6 divided by 15.2, did you get 40.26 degrees? Anytime you press one of these buttons, your answer is an angle. Now, that angle came out in degrees because my calculator's set in degrees. If I changed it to radians, that would come out as a radian measure. Well, the last one's easy. If that's 40.26, then the other one doesn't have any choice. It has to be 49.74. Again, the angles of a triangle have to add up to 180. So once I know two of them, the third one is set. Quit watching the clock. This is fun. All right, word problem 6. Here we go. From a point 340 feet away from the base of Peachtree Center Plaza, the angled elevation to the top of the building is 65 degrees. Find the height of the building. Here's my building. We are allowed to assume buildings, trees, people, poles are all vertical. You're allowed to make that assumption unless you're told otherwise. So here's my building standing straight up. There's a point 340 feet away from the base of the building. Somebody is looking up at the top of the building. This is called your angle of elevation. That angle is 65 degrees. We want to find the height of the building. Now, does my picture make sense to you? You did these in geometry with Mrs. Hastings Smith. Does that picture look okay? Now, pick a function, sine, cosine, or tangent. Let's stick with the big three since we have those buttons. Would this be a sine, cosine, or tangent problem? How do you know it would be tangent?
Opposite.
You know nothing about the hypotenuse, right? This involves opposite and adjacent. So tangent angle, tan 65, equals opposite over adjacent. Again, that's a degree, so on my calculator set in degrees, I'm all good. So 340 tangent 65. You get 729.13?
Yep.
And that unit will be the same as this one. That was feet, so it's that tall. 729.13 feet tall. Alright, so I got a tripod 5 feet above the ground. I got an 8-degree angle of elevation above the horizontal at the top of the tree. Okay. Here's my 5 feet tall tripod. I'm looking up at the top of the tree. Now the angle of elevation is going to be right here. The angle you look up through, that's your angle of elevation. And the tree is 120 feet away. And I want to know how tall the tree is. Okay, what's your thought here?
Can we just add 5 to the final answer when we're done?
So we can extend this all the way across and call this right here X.
Plus 5.
And then, once I figure out what X is, I'll add 5 to it. So how do I figure out what, now keep in mind that dashed line is also 120, isn't it? So, are we tangent again?
Yeah.
So tan 8 equals X over 120. 21.86 for the entire tree. Last one for the day here. Okay, so we know there is another right triangle whose sides are 3, 4, 5, right? The Pythagorean theorem is called the Pythagorean triple. 9 plus 16 is 25. This is not one of our special ones in that it's not like 30, 60, 90, 45, 45, 90, but it is a Pythagorean triple. And your job is to find the measure of the smallest angle. Now, the way I drew my picture, which one is, let me label them, A, B, and C. Which one is gonna be the smallest angle? C. And how do we know C is? Because it's across from the smallest side. That's the hinge theorem, the bigger the side, the bigger the angle, and vice versa. So your job is to find angle C. Now, since you know all three sides, could you use any function? Okay, so which one do you want to use?
Sine.
Sine? I like sine too. I like tangent better, but sine's fine. So sine C will equal what? Here's your angle, 3 over 5. So C is the angle whose sine is 3/5. Second sine 3/5. Did you get 36.87 degrees? Now, just for fun, change your calculator to radians, and you're gonna get an entirely different answer, but it's the radian equivalent of 36.87. So, mode, radians, second sine 3/5. Did you get 0.64? That's the radian measure of the angle. All right, peeps, we'll start 4-3 tomorrow. You did great today. 4-2 is also due Wednesday. Vacation's over.